this Jamboard is designed to show the students how to break a difficult problem into component parts that are easy. So you start out by just verifying with them that these multiplication by 10 is easy. And if they don't know the pattern for how to multiply by 10, just spend some time on this, and until they see the pattern that multiplying by 10, you just put a 0 at the end. And then you go on to the second slide and just confirm that these addition problems are easy for them. So after you get them to agree that multiplication by 10 is easy and those addition problems were easy, then we turn to this slide. And now this was far more difficult for kids than I thought it would be, but it was very revealing, the things that it told me that they didn't understand. So I had them write the multiplication problem for this, and that was easy. And some of them use a pen, and some of them use the letters. But that this is 2, and what do we got here? 2, 4, 6, 8, 10, 12, 14. This is 14. And 2 times 14 is a harder math problem, so they write 2 times 14. And now here's where my surprise came in that they didn't understand. The first time I did this 3 times with the girls that I'm tutoring. And I've got 2 of the AmeriCorps girls and then a granddaughter and one of my neighbors. And all of them had this same misconception. So we took, I took these, let's see, and moved them over here. So that now this is 2 by 10, and this one's 2 by 4. They had no problem with that. And, you know, then they changed this to 10. And this to 4, 2 by 4. You know, I have them write it. They erased. They're much neater than this. But what they didn't understand, I wanted them to see that now we can break this into 2 times 10 plus 2 times 4. And they knew this is 2 times 10 and this is 2 times 4, but they didn't know what that had to do with 2 times 14. What they didn't know, and it took a lot of conversation for me to figure this out, they didn't know that the number of squares here is the answer to the multiplication problem. They knew that when you see an array, you write the problem and you give the answer, but they didn't know that that relates to the number of squares in the problem, which, I mean, like I said, it took quite a bit of talking to them to discover that they didn't know that, because they knew to write the problem, and they, when we did smaller arrays, they'd put the answer because they knew the answer to the multiplication problem, but they didn't know what that had to do with the number of squares in the array. Like I said, I never would have thought that, because it looked like they knew what they were doing. So after we worked with this lesson for 3 different sessions, then they understood. And what I ended up doing, I modeled it for them. So we go to this new one here, and to be a little neater, let's see, this is 3 times 3, 6, 9, 12, 13, 14. This is 3 times 14. And I told him I want you to write the problem and then get the pen and circle 10, because we want to pull it out. We want to do 10 at a time. And it's easier for them to circle it than it is to move to make it 2 separate arrays. And then get a different color pen and circle these. And then tell me, and then this was after we worked for 3 sessions to reinforce, to teach and confirm that the number of squares in this block is the answer to the multiplication problem of 3 times 10. So this is 3 times 10, which is 30. And this one is 3 times 4, which they know is 12. And then that is 42, so this answer is 42. And like I said, this took 3 sessions with all 4 girls that I work with for them to understand this. And then to make it, after they finally got it, but first they had to get that the number of blocks in the array is equal to the answer to the multiplication problem. They knew how to write the correct multiplication problem for an array, and they knew how to answer that, but they didn't know that that means that's how many blocks are here, which, like I said, I never would have thought. But they, after 3 sessions and just playing with these and doing different array problems, then we got to the point where they could understand that we're breaking this up. And then we did some without drawing the array. This maybe was either in the 3rd or 4th session with most of the girls, where they then understood to the point where they could do this without drawing the array. They could picture it that 3 times 14 is the number of blocks in that 3 by 14 array, and that you can break it up into 3 times 10 plus 3 times 4. And then they could even sometimes do it in their head, which made them feel smart, that they could multiply that in their head and get the right answer. And then the one girl who did totally understand this by the end of the 4th time I did this with her, I challenged her that I'm going to have her tell me how might we do 23 times 24 next time. So we'll see what she comes up with.